Hayes last year. So if you had any of the geometry teachers, they did split the middle for these kind of trinomials. If you were at Dempsey, you did, I think someone said like divide, slide divide bottoms up or something. Is that what they called it? That's what we used to do. I don't know. No, he didn't do split the middle, right? He did something with like divide the middle term and then or divide the first term out. Yeah, slide divide bottoms up. So I don't do that here. We used to teach that, but now at Hayes, all the math teachers teach split the middle. You can do whatever factoring method makes you happy, whatever works for you. I'm going to do split the middle. So if you don't like that and you want to do guess and check, or the airplane method, or whatever other weird name you have for stuff, go for it. Okay. What do we do split the middle here when we have a trinomial? First, we look for a GCF. Is there a GCF? No. Okay. So here's how this works. We multiply the first coefficient times the constant. 3 times 4 is 12. I want to find two numbers that multiply to 12 and add to 13. 12 and 1. That one's not hard. So I'm going to take 12 and 1. Now this method I'm going to use for trinomials is called split the middle. The way it works is the first term stays the same, that 3x squared. The last term, you don't have to draw the arrows if you don't want, stays the same. Right? 4. The middle is what gets changed because we're going to split it up from 13 into 12 and 1. So instead of 13x, I'm going to rewrite it as 12x plus 1x. See how I just split that middle term up into 2? So now from here, I have 4 terms. What factoring method uses 4 terms? Grouping. We did that yesterday. So from here on out, if you're good at grouping, you can factor this the rest of the way. So I group my first 2 terms. What's the GCF for the left? 3x. I pull a 3x out, and I'm left with x plus what? 4. Now what's the GCF on the right? You have to pull something out. Normally we don't pull this GCF out, but 1. All right, for split the middle and grouping, if you have a GCF of 1, you need to divide that out. I know we typically don't pull out a 1. Okay? Good things happen when I have x plus 4 for both parentheses. So how do I write my final answer? 3x plus 1, bless you. Bless you again. And x plus 4. And that's it. Bless you a third time. And that's it. How could you check your work if you wanted to? FOIL. Distribute. Yeah, and you could do it in your head, but I will check your work on some of these. Make sure that you're right. Okay? All right, let's do another one. We're not going to do all of these in this section, but I do want to try a couple. Why don't we try number 3? Oh, those numbers are bigger. First of all, do we have a GCF? Probably. Anyone know what it is? There's an x squared, but there's a number in it too. So see if you can figure out what number goes into all 3 of those. Taylor's got it. What is it, Taylor? 3x squared. So I'm going to divide 3x squared out of both. Now, if you didn't divide 3x squared out, 1, it wouldn't be completely factored. 2, you can still do split the middle. The numbers are just going to be really big, and it's probably going to take you longer, and you're going to get a headache. So I divide out 3x squared, and I'll be left with 3x squared minus 25x plus, let's see, 42. Right. So now I just split the middle, just on the inside part. Okay, this 3x squared stays in front. It's just going to kind of tag along for the ride now. We're still splitting the middle just on the inner part. I have to figure out what is 3 times 42. Well, I think it's 126. We just did that. So 2 numbers that multiply to 126 and add to negative 25. Take calculators. Take a minute. If you need a strategy here, I would start taking 126 and taking 1 times 126. Not going to get me to 25. 2 and 63. Not going to get me to 25. 3 and 42, so on and so on. And go through your list there.
Negative 18 and negative 7.
Yeah, negative 18, negative 7. So I'm going to flip my middle with -7, -18, or -18, -7. Do you think it matters what order I write those in the middle? No. So which one do you want to do first? It doesn't matter. 18. All right, so we'll do 3x squared minus 18x minus 7x plus 42. Now, if you flipped those middle terms, you would get the same answer when you're finished. So I still group. I still look at these first two and the last two. It's just my 3x squared is still hanging out in front of everything. What's the GCF on the left? 3x. So when I pull that out, I get x minus 6. What's the GCF on the right? Notice the term is negative, so it's going to be a -6. No, it's not. -7. Sorry. All right, what's left in the parentheses then? Yeah. So my final answer has 3 factors. You have to include the GCF in front. 3x squared. What would be your next factor that you want to write? 3x minus 7 and x minus 6. And that would be your fully factored form. So a little bit bigger numbers. Always look for that GCF to help you out. Okay? Let's do one more from this section, and then we can move on. I'm going to do number 5. Number 5 looks trickier because there are 2 variables, x and y. So don't let that freak you out. It's still a trinomial. We're still going to do split the middle. We'll talk about the letters in a minute. But for now, let's talk about the numbers. 6 and -10. Multiply those together and find 2 numbers that multiply to -60 and add to -11. What do you got? Yeah, -15 and 4. Okay. So I'm going to split the middle here. I'm going to take my 6x squared, and then my last term is -10y squared. And when I split the middle here, what variables go with the -15? X, y. Notice that the middle up here has an x, y. So when I split the middle, I still need the x, y there. So I have -15xy plus 4xy. Because those 2 middle terms have to add to -11xy. And now we group like we have been. Alright, so let's write GCF on the left. 3 what? X. 3x. And so I'll be left with 2x minus 5y. Good. And then let's write GCF on the right. 2y. Positive 2y. And I'll have 2x left here minus 5y. So my final answer is 3x plus 2y, those GCFs, and 2x minus 5y. So it wasn't that bad, right? It looked weird because there were different variables. Not too bad once you get it. Yes? Alright, so are we going to split the middle? You remember doing those? Let's do another one that you've probably done before. We'll skip the practice, flip over to the next page. Difference of squares. Now this is a special case. Difference of squares is not hard. So none of these factoring methods on their own is challenging, in my opinion. But it's when you mix them all together that you you forget which method to use or how to do it. Difference of squares for some reason is super easy, and then you get to your factoring test or practice where it's all mixed together or a different concept, and you totally forget that this one exists, and you just don't know what to do. The difference of squares is a pattern. So you need a binomial, 2 terms. Difference, what sign is for difference? Minus, subtraction, so it has to have a minus sign. And then squares means that you can take the square root of each of the terms. They're perfect squares. So if I have 4a squared, I'm going to take the square root of that. What's the square root of 4a squared? 2a. Right? Now, I'm going to write it down just because some people need to see that. If you don't need to write it down, you can skip to the answer in a minute. Then I take the square root of 9b squared. Not negative 9b squared, just 9b squared. Ignore the negative. The negative is there to tell you what factoring method to use. What would that term be? 3b. All right, now, who remembers what I do with the 2a and the 3b? I'm going to have two binomials here. I do 2a, so the first guy, the square root of the first term comes down. 2a goes in the front of both parentheses. There gets to be a 3b in both, a 2a and a 3b. And what signs go in there? A plus and a minus. Now, does it matter if I do plus first or minus first? No, pick your favorite way. And that's it. So when I get to something like number 2, again, I have a minus sign, so I'm allowed to do difference of squares. What's the square root of x squared, y squared? xy. Okay, what's the square root of 1 over 16? 1/4. Yeah, if you're taking the square root of a fraction, you take the square root of the numerator and the square root of the denominator. All right, so if I write my factored form here, I put xy first in both parentheses. I put 1/4 second, and a plus, and a minus. That's it. Now, I know there seems like there's a lot of examples here, but there's a couple I just want to run through. So let's look at number 3. 12x squared minus 27y squared. It has a minus sign, so that's good. Can I take the square root of 12 and 27? No. What do I need to do first? GCF. What's the GCF? 3. So I'm going to divide out of 3. We'll have 3 times what? 4x squared minus 9y squared. And from there, then, you should be able to say, okay, I can take the square root of those terms. My GCF still hangs down the front. I still want the 3. What's the square root of 4x squared? 2x goes in both. And 3y. Your plus, or your minus. And that would be fully factored. All right, now the next row makes them look a little bit more complicated. Are we good so far? Okay. Negative 81 plus a to the 4. Doesn't have a minus sign. No, but here's the thing. We'll see this a little bit, like a different case of this in a minute. This one's minus, right? Are they both perfect squares? Can I take the square root of both? I can. So here's what I want you to do. I want you to rewrite this. I want you to flip those as a to the 4 minus 81. You are allowed to do that as long as you don't change the signs of anything, right? The 81 is still negative, the a to the 4th is still positive. I can now do difference of squares here because now I have a minus in the middle. So when I take the square root, what's the square root of a to the 4th? A squared. So I'm going to have a squared in both. And what's the square root of 81? 9. So I have a plus 9, bless you, and a minus 9. Now here's the thing that gets us sometimes. That's factored. Is it completely factored? What can I still do? Which one? First set or the second? Which one's still factored? This one has a plus. The second one, I can do difference of squares again. I'm not done here. A squared plus 9, that's prime. That's a plus. I can't factor it anymore. So it stays the same. It's finished. The second guy, I can do the whole difference of squares over again. What's the square root of a squared? A. Square root of 9? 3. Plus and a minus. Now that whole thing would be considered completely factored. Okay. All right, what if I look at number 5? We have high exponents again here. M to the 6th and 16 m to the 4th. What's the square root of m to the 6th? M to the 3rd. If you're not sure about that, if you have any exponent higher than 2, like to do the square root, you just divide it in half for the square root. What's the square root of 16n to the 4th? 4m. Yeah, 4m squared. So I'm going to do 4m squared, a plus and a minus. Now, can I do any more factoring there? Yeah. Which one? Can I take the square root of m to the third? Is that an even number? No, so actually I'm finished. That's your final answer. I know it looks like it because there's a 4m squared, but you can't take the square root of m to the third. So that would just be it. Okay? Last one, then we'll do a different method. Number 6, 2 log of the fourth plus 32 to the fourth. What should I do first? They have a GCF. Alright, I can't do difference of squares when they're not perfect squares. I factor out of 2, and I'll have y to the fourth plus 16 z to the fourth. Alright, those are both perfect squares in the parentheses. Can I factor it? Nope, I can't. Why not? There's a plus sign, and we're doing difference of squares. That would be sum of squares. That's impossible. That doesn't work. So that's actually your final answer right here. Right? Now, in the past, things I've seen, like this part in here, this is considered prime. The whole problem, however, that we started with is not prime because you did pull out a GCF already. You already factored it. You just can't factor it anymore. So, like, I remember seeing a similar type of question on last year's Factor Master test, where people were writing prime after this because they couldn't factor this part. But it's not prime. The whole thing you've already factored. All right, so prime only is when there's absolutely nothing you can do. No GCF or anything. Okay? All right, remember difference of squares, okay? Now the next one, we'll skip the practice. Sum and difference of cubes, another special case. You were taught this if you were at Hayes last year. 9th graders, did you learn this? So, no? Okay, so if you're a 9th grader, you'll catch on. If you're a 10th grader or 11th grader, it's review for you. Okay? Fancy method, there are not really formulas, but patterns up here. You can look at those if that works for you. I have a way to show you that I think people usually catch on pretty quick. So I try not to lean too heavily on these patterns because you have a lot of stuff in your brain already. You don't need to memorize the formula. Okay? So sum or difference of cubes. This one works again with a binomial. There are 2 terms here. And cubes, perfect cubes, things you can take the cubed root of. You guys know how to take the cubed root on your calculator? Anyone not know how to do it? Okay, pull up your calculator really quick. Let me show you before we move on. It's going to be helpful for you. Just in life and in class, we'll use cubed root, 4th root, 5th root, as the year goes on. I'll just show you cubed roots today. Alright, so cubed root. Fastest way to do it would be to hit math on the left-hand side, if you have the regular T84. And which one here looks like it's the cubed root? Number 4. So you would hit number 4, and then it just brings you the cubed root. So in this first column, I want the cubed root of 125. So you can just type that in and hit enter. There is a way to do like 4th root and 5th root. I'll show you that as we need it during the year. But cubed root is all we're going to do for you. Okay? So does that help? Now you know. So I have 2 perfect cubes. This one has a plus sign. That plus sign is going to be important later. Now the way these factor is you're going to factor this into a binomial. So I'm going to put blanks here for now. If this is brand new to you, maybe do this for the first problem or 2. You don't have to do the blanks, but that's how I teach it. You get a binomial, and then you're going to have a trinomial with 3 terms. So a short set of parentheses and a long set of parentheses. We're going to fill in the binomial first. The way I do that is I take the cubed root of x cubed. What is that? X. Okay, so I'm going to put an x in the first blank. The cubed root of the first term goes first. Now, I'm going to take the cubed root of 125. We already did that. What's the answer? 5. 5 goes in the second blank. Don't worry about signs yet. I will come to the signs at the end. I want to fill in the blanks first. So I took the cubed root. I have an x and a 5. Now, let's deal with our trinomial. To fill in the first blank of the trinomial, you square the first guy over here. What's the square of x? X squared. To fill in the last blank of the trinomial, you square the 5, which is 25. Now to find the middle term, does anyone remember? You multiply x and 5 together and get 5x. Okay. So that's factored for. Now we gotta do signs. We use an acronym called SOAP. You see SOAP up here. SOAP, I'll write it over here. Some people call this the SOAP method of factoring. Anyone, any sophomore, junior remember? S stands for same. O is opposite. A, always what? Positive. Now, if you're a freshman, you've never seen this before, that doesn't mean anything to you. That has to do with the plus and minus signs. So here in the problem, to start, your first sign in the original was plus, right? So the same sign goes first. Same. Next blank gets a opposite, so a minus sign, opposite of plus. And the last one is always positive. Now I factored it. Now we have a trinomial. I can't do anything to the binomial. Let's look at the trinomial. Let's make sure. Can I factor this? So this is what we did yesterday. So let's see. Two numbers that multiply to 25 and add to negative 5. What numbers multiply to 25? 1 and 25, 5 and 5. Can any of those add to negative 5? No. Now I did that on this one. This is it. This problem, or this trinomial, is always prime. Now you can never, ever factor this trinomial when you do the method. So after you get here, you're finished. All right, let's try now. It's mostly just memorizing where things go. Number 2, 8x cubed minus 1. So I start, again, I'm going to have a binomial and then a trinomial. I take the cubed root first. What's the cubed root of 8x cubed? 2x. So put 2x in my first blank. What's the cubed root of 1? 1. Don't worry about the negative sign, just do the number. Cubed root of 1 is 1. Now let's fill in the trinomial, then we'll do the signs. The first blank, I square 2x. What is that? 4x squared. To get the very last blank, I square the second number. What's the square of 1? 1. And how do I get the middle? Multiply. 2x times 1 is 2x. Okay. Now again, I do my signs. So, same. So I started here with a minus sign. So what do I start with here? Minus. Same. Opposite. Always positive. Not too bad. Let's see. I don't know how many of them there are. Okay, there's a couple more. We won't do all of them. But let's see. Let's do 1 or 2 more. We're almost done for the day. Pick another one. 3, 4, 5, or 6. 5. Yeah, 5 looks yucky. Let's do 5. Okay, 8x cubed plus 27 over 64. It just looks gross because of the fraction. It'll be okay. So 2 blanks, 3 blanks. And we had a big because that was fraction. Alright, start with the cubed root. The cubed root of 8x cubed. 2x. Okay, now, you can do the cubed root of 27 over 64 in your calculator if you want. So if you wanted to go there and do the cubed root of 27. Oh, wait, hold on. I'll do it this way. Do you guys know how to make a fraction in here? How do you do it? Remember? How to make a fraction that stacks?
Alpha, y.
Yeah, alpha, y equals enter. And I'll show you guys at any time if you need. Alpha, y equals enter makes the little fraction like this if you want it. Might be helpful as you go through the year. You can type in 27 over 64. Now, might give you, gives me a fraction. If it gives you a decimal, does anyone get a decimal when they, I know you guys know like 3/4 as a, like decimal, but do you guys know how to change decimals to fractions?
It's alpha, y.
Yeah, that's how you get a fraction, but if I got, like, say I had like 0.75, like if that's what your calculator gave you.
That went in alpha, y, and then 4.
Oh, I always just do math Enter, enter. Because this changes it from to a fraction. Here, enter, and then enter, and it would turn it into a fraction. So math enter, enter. Turns the decimal to a fraction, and you can do the opposite as well. All right, so I have 3/4. So let's see. So I'll put 3/4 here. So how do I fill in the first blank? What's 2x, the quantity squared? 4x squared. Okay. Last blank here. What's 3/4 squared? 9/16. You square the numerator and the denominator. And then what's 2x times 3/4? 3/2. Yeah, so that's 6/4, which is 3x/2. All right, then you do your signs. Start with same, so plus. What comes next? Minus. Always plus. Anything else that look complicated on that one? Maybe number 4. Let's do number 4. Then we'll be done with these. We're almost done. We got like 2 examples left. Let's go back to 4. X to the 6th minus y to the 3rd. Alright, so I start with x to the 6th. What is the cubed root of x to the 6th? X squared. What would be the cubed root of y cubed then? Y. Okay. So I take x squared and square it. X to the 4th. Okay, and then for y, I square y and get y squared down here. And what do I get when I multiply them together for the middle term? X squared y. Okay. Just lots of x's and y's. I want to make sure you were okay with the x. Signs. I start with a negative. Same. Opposite is a plus. And then always positive. Okay. Feel good on so? All right, we're almost there. Go to the very bottom of your page. Very bottom says method 7. Method 7 is really just factoring what we call quartic polynomials. We'll talk about that at the end of the year. But exponent of 4th, degree of 4. These look more complicated than they are. How many terms are in that problem? 3, right? So it's called a trinomial. So you're actually going to factor this just like the trinomials we factored yesterday. This is a coefficient of 1 out in front. So we'll deal with the exponents in a minute, but for now, just come up with 2 numbers that multiply to -4 and add to -3. -4 and 1. Okay, now here's how it's going to factor. Yesterday, when we factored our trinomials, we just ended up with 2 binomials, right? So we would put these numbers in, -4 and 1. And we had an x and an x, right? Well, what do you think is going to be in front this time since it's x to the 4th? X squared and x squared. Okay? So it factors the same way. Instead of x in front, you have x squared in front. Now I look at that. Can I factor either of those anymore? Which one? The first one. What factoring method can I use to factor x squared minus 4? Difference of squares. It has a minus sign and I can take the square root. What does that factor into? Can you tell me the factors? X plus 2 and x minus 2. And then you have to put the x squared plus 1 next to it. If you don't, it's not actually fully factored. You didn't do the whole thing. So that's it. Why can I not factor x squared plus 1? Because that's plus. Good. All right, last one. Same idea, but this time I have a coefficient. So what method should I use to factor that trinomial? Split the middle, or whatever guess and check you like to do. So we're going to multiply 3 and -20. -60. What numbers? Multiply to -60, add to 7. Positive 12, -5. Alright, so we're going to split up the middle. 3x to the 4th. Plus 12, what's the exponent here? X squared, because I have an x squared in the middle up here. So I need 1 down here. Plus 12x squared minus 5x squared minus 20. You can work ahead of me if you need to here, but we're going to group and pull out our GCF. I'll pull out a 3x squared, and I'll have x squared plus 4. And what's the second GCF? Minus 5, yeah, because it's minus here. So I pull out a negative 5, and I'll have, x squared plus 4. So my final answer is 3x squared minus 5, x squared plus 4. Okay, so today, to finish up, I want you guys to try any